Hello students, are we ready for the next problem? All right, let's do it. And it says, which expression is equivalent to x to the fourth power times x to the seventh power? So I'm looking for something that is equivalent to that. Okay, so there is a rule that you should have memorized it by now, but if you haven't, it's okay, because you can always try to understand the concept. So before I give you the rule for that, let's see if you remember what it means by x to the fourth power. Well, x to the fourth power means that I need how many x's? I need 4 of them. Very good. So I got 4. But then I have another x with an exponent of 7, which means now that I need how many? 1, 2, 3, 4, 5, 6, and 7. So the first 4 are for the first term. The next 7 are for the second term. If you count all of them together, how many x's do you see? Very good. You see 11. So there is a rule that I want you guys to remember to use, and I have it, I'm hiding it somewhere over here. Let me see if I find it. Yeah, it's right there. Okay, so my rule says if I raise the same bases to 2 different powers and I'm multiplying, I'm finding the product, I need to add the exponents. Add the exponents. Very good. So in this case, I'm going to rewrite it down here. It means that x has the same base than the second one. So the 4 will be added to the 7. And that's how I get x to the 11 power. Very good. Okay, let's do the next question. The next problem says, simplify the following expression. So one of the things that I need for you to remember, hopefully you do, is what happens anytime that you raise anything to a 0 power. No matter what I raise to a power that has a 0, I will always get a 1, no matter what it is. Okay, so I'm going to rewrite it. So my problem now is going to be 1 times x to the fourth power. What happens anytime that you multiply by 1? 5 times 1, 5. 10 times 1, 10. Don't you always get the same number? Exactly. So my answer, this will be x to the fourth power. Very good. Let's go on to the next problem. Question says, simplify the following expression. So notice how in this question, now I do see more variables, not just one. So the whole idea on these questions is that you can only combine the ones with the same base. Is that correct? And the rule that applies for this one is still going to be the product rule. Okay, so let me put it up here. Why am I still going to do the product rule? Because I do see parentheses. And parentheses means multiplication. So basically, my problem, I can rewrite it as x to the third power times y to the sixth power times x to the negative second power times y to the third power. And remember, you can only combine, or you can only apply the rule for those terms with the same base. So for example, I can combine, or I can apply the rule for this one and this one, because both of them have x's. Is that right? So I'm going to ask you to rewrite it. And the rule for the product rule says that I need to add the exponents. Very good. So if I need to add the exponents, my exponent is a 3, and I'm going to add the negative 2. Is that right? So that gives me x to the first power. Now, the next one that I can combine will be y to the sixth power, and I have y to the third power. I need to add the exponents. Remember? Because the rule says you need to add the exponents. So this will give me y to the 9 power. Therefore, my answer will be x y to the 9 power. Is that right? Because the 1 for the x is not needed. So this is my answer. Let's go on to the next problem. And the question says, simplify the following expression. Now, I don't know if you noticed, but it kind of gets more complicated as we move on, right? Because now, I don't know if you see that, but this one has a coefficient. Do you guys see that? There is a coefficient right here, which is 4, and a coefficient that is a 6. Neither one of those two coefficients are being raised to any powers. There's no powers. The 5 is raising the x to the 5th power. Do you guys see this? This is x to the 5th. This x is x to the negative 2nd power, and the y is y to the 4th, and this y is y to the I'm going to put a 1 so that I don't forget that. Anytime that there's no power, it's understood that it's a 1. So the first thing I need to do is I need to multiply my coefficients, right? So I'm going to multiply 4 times 6, and I get a 24. Everybody with me? Okay. Now let's take care of the exponent, the basis, right? So I'm going to go with x to the 5th power. Since I am multiplying, what do? I need to add the exponents. So the other x has a negative 2. So I'm going to say plus negative 2. And that will give me x to the 3rd power. Very good. Because I need to subtract the 5 and the 2 because they're not both positives. What about the y? Well, the y had no power, but I wrote a 1 because it's understood that it has a 1. What about the second y? It has a 4 as an exponent. So I need to add them up, and that gives me y to the 5th power. I'm going to rewrite my answer. So my answer will be 24 x to the 3rd power, y to the 5th power. And yes, this is my answer.